When you look at a scientific test result, maybe a product safety claim, or even a medical diagnosis, how do you actually know it's reliable? Like, really trust it? What's the hidden machinery, that, that system behind the scenes that ensures that confidence? It's not just blind faith. There's a really powerful framework making it happen. Today, we're kind of pulling back the curtain on that exact framework. We're taking a deep dive into ISO IE 14025.2017. Now, I know that string of numbers might sound a bit dry, but trust me, don't let it fool you. This isn't just some standard. It's basically the global gold standard for lab competence, impartiality, and making sure labs operate consistently. It's really the secret sauce, the hidden backbone, ensuring scientific integrity, making sure those numbers you rely on are solid truths.
That's absolutely right. And for our deep dive today, we're leaning heavily on a really comprehensive guide called ISO IEC 14025 Auditor Training, a clause-by-clause guide. It gives us this unique viewpoint because it details exactly what auditors, the people checking the labs, are looking for. It's like we've got the auditor's playbook right here.
Exactly. So our mission today is to unpack this standard, go clause by clause. We want to show you the specific details, the tasks auditors perform, and why it all matters for ensuring a lab is truly trustworthy. We'll explore why each bit is crucial, sort of giving you a shortcut to understanding what underpins reliable science.
Yeah, and fundamentally, ISO IE 17025, it isn't just bureaucracy for bureaucracy's sake. It's the global way we build and critically maintain trust in test and calibration results worldwide. It hits on those key things. Competence, can the lab actually do the work properly? Impartiality, are they biased? And consistent operation, do they do it right every single time? Without these, the data you get is, well, it's just numbers on a page. With them, it becomes reliable insight you can act on.
Right. Okay, so let's start where trust really has to begin. Clause 4. General requirements. Think of this as laying the ethical foundation. The first step is 4.1, impartiality. This isn't just like a nice thing. It's absolutely fundamental. Making sure decisions, test results, they're not swayed by any pressures, internal or external. It's the bedrock for unbiased data.
And auditors, they treat this as absolutely critical. They're not just looking for a piece of paper, a written policy saying we are impartial. Oh no, they'll dig into potential financial links, maybe between the lab and its clients. They check for staff, declarations of interest, conflicts, and crucially, they talk to the staff, they interview them, they understand the lab's culture. How do people actually handle potential pressure? Or maybe subtle biases? Because, the perception of impartiality is almost as important as the reality when you're building trust.
That's a really key insight. It's about more than just stopping obvious bribery or something. It's preventing even the hint of a hidden agenda or maybe a financial incentive skewing results.
Yeah.
Making sure the science stands alone. Okay, still in Clause 4, we've got 4.2, confidentiality. So beyond being fair, labs handle super sensitive stuff, right? Cutting-edge research, maybe proprietary company data, personal health info.
Exactly. And this clause is all about protecting that information. Auditors look at the formal confidentiality agreements, sure, but they also evaluate access controls. That means digital security for databases, passwords, encryption, all that. But also physical access. Who can get into the file room? Who sees sensitive documents? And they watch how data is actually handled day to day. Are procedures being followed? It's about locking down that sensitive info, whether it's trade secrets or personal privacy.
Makes sense. So for you, the listener, this means your sensitive research data or maybe proprietary product details or even your personal medical test results. They're kept safe, confidential. Just as they should be. All right, let's shift gears. Clause 5, structural requirements. Now, this isn't about the physical building.
No, not the bricks and mortar.
Right. It's about the organizational blueprint, the lab's legal and operational structure. The whole point is making sure the way the lab is set up inherently supports doing good, impartial work.
Yeah, think of it like the lab's skeleton. Auditors check the lab's legal status. Is it properly registered, licensed? They look closely at org charts. Who reports to whom? Are roles and responsibilities crystal clear? And critically, they verify that technical decision-making is truly independent, that it's separate from, say, commercial or sales pressures. Is the lab manager making technical calls, or is the sales director?
Ah, I see. It's like ensuring a house has a solid, legally approved foundation and a clear plan before you start building the complicated stuff on top.
Precisely. Get the structure right, and you got a better chance of everything else being right, too.
That makes perfect sense. Okay, foundation laid. Now, Clause 6, resource requirements. This is where we get into the tangible stuff, the people, the place, the tools needed for precision. Let's start with 6.2, personnel. The goal seems simple. Make sure everyone working there is competent, qualified for what they do.
Simple goal, maybe, but checking it is pretty involved. Auditors review job descriptions, naturally. They look at training records. But what's really interesting is they often scrutinize something called the competence matrix.
Competence matrix, what's that?
Think of it like a detailed skills map for the whole lab. It charts out all the required skills and techniques for different roles, and then maps which staff members have been assessed and proven competent in each specific area. It's not just about having a degree, it's about demonstrating ongoing practical competence. They'll also check if the training is actually effective, and they'll talk to staff, ask them about procedures, gauge their real understanding.
So it's not just about hiring qualified people initially. It's this continuous process of making sure they stay proficient, especially as science and tech evolve. It's about being perpetually ready.
Exactly. Perpetual readiness. I like that.
Next up, 6.3 facilities and environmental conditions. This one seems pretty straightforward, controlling the physical environment so it doesn't mess up the results.
Right, but the devil's in the details. Auditors inspect logs for things like temperature, humidity, sometimes even vibration levels, all things that can subtly or not so subtly affect sensitive measurements. They also look at lighting, ventilation, general cleanliness, separation of incompatible activities. Imagine trying to measure trace contaminants in a dusty room or run sensitive electronics next to a big centrifuge.
Yeah, you can see how that would be a problem.
Yeah.
Okay, so the environment's controlled. What are the tools themselves? 6.4, equipment.
Yes. Equipment. The objective here is clear. Make sure every piece of equipment is suitable for the job, it's properly calibrated, and it's meticulously maintained.
So auditors are checking.
They dive into the equipment register, that master list of everything the lab uses. They check calibration certificates. When was it calibrated? By whom?
Yeah.
Is the calibration provider accredited? They look for calibration labels on the equipment itself. And they review maintenance records. Is preventative maintenance being done? Is broken equipment taken out of service correctly? It's about ensuring every instrument is trustworthy.
And this calibration aspect, it leads directly into something really fundamental in science, doesn't it? Metrological traceability.
Yes. 6.5 metrological traceability. This is kind of a cornerstone concept. It's about ensuring that every measurement the lab makes can be linked back through an unbroken chain of comparisons to fundamental standards, usually the SI units, the International System of Units, or sometimes to certified reference materials.
So how do auditors check that chain?
They literally trace the calibration chains. They'll pick a piece of equipment, look at its calibration certificate, see what standard it was calibrated against, then look at the certificate for that standard, and so on. Following the chain back and back until it connects to a national standard held by, say, NIST in the US, or NPL in the UK, or an equivalent National Metrology Institute. Or maybe to a recognized certified reference material producer. And they confirm the lab uses accredited calibration services for this, ensuring the competence of those providing the calibration.
Wow. So it's like a scientifically precise family tree for every single measurement. That's what allows results from different labs, different countries, even different decades to be reliably compared because they all trace back to the same ultimate reference point.
That's the aha moment right there. It's what underpins global scientific comparability and coherence. A meter measured in Paris is the same as a meter measured in Seoul.
Incredible. Okay, one more in Clause 6. That's 6.6, externally provided products and services. What's this about?
It's about making sure that anything the lab buys or uses from outside sources, things like chemical reagents, calibration services, maybe even specialized tests they subcontract out, meets their own strict quality requirements.
So extending quality control beyond their own walls.
Precisely. Auditors check how the lab evaluates its suppliers. What are the purchasing procedures? Are incoming goods inspected? Are outsourced services verified? It's managing the risk that comes from relying on others. Quality needs to be end-to-end.
Okay, that wraps up the resources. Now we hit Clause 7, process requirements. You called this the operational heartbeat earlier. Sounds like this is where the day-to-day lab work really gets scrutinized.
Absolutely. This clause is huge. It covers the entire journey of a sample or test item, from the moment the request walks in the door until the final report goes out. It's all about ensuring integrity at every single step.
Right, so break it down for us. What's first?
First is 7.1, review of requests, tenders, and contracts. The lab has to be absolutely clear on what the customer needs before they start. Auditors check the contract review process forms, records, making sure the scope, the methods to be used, the requirements, it's all understood and agreed upon. No guesswork. Then, 7.2 selection and validation of methods. Labs need to use appropriate methods for the tests, and crucially, those methods need to be validated, proven to work reliably. Auditors look at the lab's standard operating procedures, the SOPs, and the validation reports for those methods. If the lab uses non-standard methods, maybe developed in-house, they need robust documentation showing how they validated it.
Okay, makes sense. Use the right recipe and make sure the recipe works. What about getting the sample itself?
That's 7.3 sampling. If the lab does the sampling itself, this clause kicks in. The objective is controlling how samples are collected, because if you mess up the sampling...
Garbage in, garbage out.
Exactly. Auditors review the sampling plans, the procedures, the records. They check that the staff doing the sampling are properly trained and competent for that specific task.
All right, so the sample's collected properly. What happens next?
7.4 Handling of test calibration items. Once the sample is in the lab, you have to protect it. Prevent contamination, loss, damage, deterioration. Auditors watch how samples are stored correct temperatures. Secure. They check labeling. Is it unique and clear? They look at tracking systems. And they verify the chain of custody, that documented trail of who handled the sample and when. It's like evidence handling in forensics.
So meticulous tracking.
Yeah.
Then you do the test.
And you have to record everything. That brings us to 7.5 technical records. All the raw data, calculations, observations, anything that influences the results needs to be recorded accurately, traceably, and without errors. Auditors check these records for completeness. Can you follow the data trail? Is it clear who did what, when? Is there proper version control if records are electronic? It's about having a verifiable audit trail for the data itself.
Okay, and then something you mentioned earlier, uncertainty.
Yes, 7.6 Evaluation of measurement uncertainty. This is critical. It's not about mistakes. It's about quantifying the inherent doubt or variability that exists in any measurement, no matter how careful you are. Where it's relevant, labs need to estimate this uncertainty. Auditors review the lab's uncertainty budgets, the calculations they use, and check that the test methods include procedures for evaluating uncertainty. It means reporting a result not just as 10, but as 10 plus or minus 0.2, for example. It's honest reporting.
That distinction is so important, isn't it? Between making an error and acknowledging inherent uncertainty. It feels like a real hallmark of scientific rigor.
It absolutely is. Then, how do you make sure the results stay valid over time? That's 7.7, ensuring validity of results. Labs can't just assume their methods always work perfectly. They need ongoing checks. Auditors look for participation in proficiency testing PT schemes, where labs test the same blind sample and results are compared. Or interlaboratory comparisons. They also check internal quality control measures, running control samples, using reference materials, replicating tests, and if something look off, what corrective actions are taken. It's about constant vigilance on quality.
Okay, so lots of checks and balances. Now, getting the results out the door.
7.8, reporting of results. The final report needs to be clear, accurate, unambiguous, and contain all the necessary information. Auditors review examples of final reports. They check the formatting, make sure all required info is there, like uncertainty, if applicable. Look at how decision rules are applied, like stating pass-fail based on a specification, and confirm the report meets the customer's requirements. Clarity and completeness are key.
What if a customer isn't happy?
That leads to 7.9 complaints. Things can go wrong, or customers might perceive something is wrong. Labs need a documented process for handling complaints effectively. Auditors review the complaint log or register. They check the records of how complaints were investigated, what root cause was found, and how it was resolved. Is the customer informed? It's about learning from feedback and addressing issues properly.
And what if the lab itself finds something went wrong with its own work?
That's 7.0 non-conforming work. This is when the lab identifies work that doesn't meet its own procedures or the agreed requirements. The goal is to stop potentially invalid results from being used. Auditors look at the records of these instances, often called non-conforming reports or NCRs. What actions were taken? Was the work stopped? Was the impact evaluated? Was the client informed if necessary? It's about containment, correction, and transparency when things go off track.
Okay, nearly there for Clause 7. What's the last one?
The last one is hugely important today. 7.11, Control of Data and Information Management. This covers the integrity and security of all the lab's data, especially electronic data managed through LIMS, Laboratory Information Management Systems, or other software. Auditors evaluate things like software validation. Has the LIMS been proven fit for purpose? Access controls who can enter or change data. Backup procedures, is data safe from loss? And overall, data security and integrity. Protecting the data is paramount.
Wow. That is incredibly comprehensive. Clause 7 really does cover every step, ensuring that integrity is woven into the entire process, from the initial request right through to the final data management.
It really does. It's the core operational engine of the standard.
All right, so we've covered the foundations, the resources, the detailed processes. Now we arrive at Clause 8, management system requirements. This feels like it's about the oversight, the continuous improvement cycle, the bigger picture management.
That's exactly right. Clauses 8.1 through 8.3 basically set out options for establishing the overall management system. Option A is a more traditional quality system built around ISO 12025 itself. Option B allows labs already certified to ISO 9001 to integrate the 12025 requirements into their existing 9001 system. Either way, auditors are checking that there is a coherent system, that processes are documented, maybe in a quality manual, maybe not, and crucially, that the system is actually being followed in practice. It's about demonstrating systematic management.
And that system generates records, so I guess that links to 8.4, control of records.
Directly. This clause ensures that all the records generated by the system, calibration records, training records, audit reports, everything are managed properly. Auditors check the lab's policy on record management. How long are records kept? How are they protected from damage or loss? Can they be easily retrieved when needed? This ensures traceability and accountability over the long term.
Okay, now this next one sounds really proactive. 8.5, actions to address risks and opportunities. We talked about impartiality risks earlier, but this seems broader. How does a lab anticipate potential problems before they happen?
Exactly. This clause requires the lab to think proactively about risks to impartiality, risks to the validity of results, risks to meeting customer requirements, risks to its overall operations, and also to identify opportunities for improvement. Auditors will look for evidence of this risk-based thinking. They'll often review the lab's risk register, if they maintain one. They check that risks are identified, analyzed, and that actions are planned and taken to mitigate them, and that this assessment is reviewed periodically. It's about building a resilient, forward-looking operation.
And that focus on looking forward connects nicely to 8.6, improvement. The goal here is just that driving continuous improvement.
Yes. It's not enough to just maintain the status quo. The standard requires labs to actively seek ways to improve their management system, their processes, their effectiveness. Auditors look for evidence of this. Are there improvement logs or projects? Are they being tracked? Are suggestions from staff considered? And importantly, are the findings from audits and other feedback loops actually used to spark improvement initiatives? It's about fostering a culture of getting better.
So improvement is the goal, but what happens when things do go wrong? We touched on non-conforming work, but 8.7, corrective actions, seems more focused on fixing the underlying cause.
Precisely. Non-conforming work deals with the immediate problem. Corrective action deals with the root cause to prevent it from happening again. When a nonconformity is identified, maybe through an audit, a complaint, or internal QC, the lab needs a process to investigate why it happened. Auditors review corrective action reports, area Rs. They look for a thorough root cause analysis, not just blaming an individual, but looking at systemic issues. And then they verify that the actions taken actually address that root cause, and crucially, that the lab checks later to make sure the action was effective. It's about fixing the system, not just patching the symptom.
Okay, that makes sense. Now, 8.8, internal audits. This sounds like the lab checking up on itself. Let's unpack this a bit.
Yeah, it's exactly that. It's the lab's own internal mechanism for verifying that it's actually complying with the requirements of ISO AE 17025 and with its own internal procedures and policies. Auditors, the external ones, confirm that these internal audits are happening regularly according to a plan. They check that the internal auditors are competent and impartial. They review the internal audit reports and look at the follow-up actions. Are nonconformities found internally being addressed through that corrective action process we just talked about?
So it's a critical self-assessment tool. Keeps everyone on their toes between external audits.
Absolutely. It's vital for maintaining the system's health day to day.
And finally, the capstone. 8.9, management review. What's the objective here?
This ensures that top management, the lab director, senior managers, regularly sits down and formally reviews the entire management system. Is it still suitable? Is it adequate? Is it effective? Auditors look for records of these meetings, minutes, agendas. They check that specific inputs are considered, like results from audits, customer feedback, PT results, resource needs, risks identified, improvement suggestions, and they look for specific outputs, decisions made, actions assigned to improve the system, resource allocation. They confirm these actions are tracked. Leadership involvement is absolutely key. Without buy-in and oversight from the top, the whole system can falter.
Right. It anchors the whole quality commitment right at the leadership level. That makes total sense. Okay, we've gone through the lab requirements clause by clause,
Yeah.
but you mentioned auditors checking auditors. What about the people doing the checking? The auditor competency requirements, briefly, what's needed there? Is there a difference between, say, an internal auditor and a lead auditor from an accreditation body?
There is, although there's a lot of overlap in the core skills. Both need a really solid, deep understanding of ISO 17025 itself, obviously. They also need to understand auditing principles, often based on another standard, ISO 19011. And they need that risk-based thinking we talked about, good communication skills, good report writing skills, and definitely strong interviewing skills to draw out information effectively. These are foundational for any competent auditor.
And what's fascinating there is how specific and sometimes nuanced those skills need to be, right? It's not just ticking boxes. It's interpreting the spirit of the standard in a real-world lab.
Absolutely. It takes judgment and experience. The key difference, though, specifically called out in guides, is that only lead auditors typically require the specific competency of managing an audit team. Internal auditors might work alone or as part of a team, but the lead auditor has that extra responsibility of planning the audit, assigning tasks to team members, coordinating the effort, and ensuring the overall audit objectives are met. They're the conductor of the orchestra, so to speak.
Got it. The conductor. That's a good way to put it. Well, what an incredible journey through ISO IS 61225. We've really peeled back the layers today, haven't we? Seeing the sheer level of detail, the foresight that's baked into this standard, it's clear how it directly supports the reliability, the trustworthiness of lab results all over the world. From that very first sample handling right through to the final report and data management, it really is a testament to scientific rigor.
It truly is. And hopefully, understanding this gives you, our listener, a much better appreciation for the immense effort and the systematic rigor that goes into producing those facts and data you see every day. Whether it's on a food label, in a forensic report, an environmental study, or a medical test, you now have a glimpse of the meticulous, internationally agreed system working behind the scenes to make those results trustworthy. It's not magic. It's a highly engineered system focused on quality and integrity.
So maybe here's a final thought to leave you with. As you go about your day and encounter various claims, data points, test results, how might understanding this deep systematic commitment to impartiality, to competence, to consistency required by standards like ISO IC 17025, how might that change the way you evaluate your credibility? Could it perhaps encourage you to ask sharper, more informed questions about the data you rely on?